So in this problem, a 5 kilogram box is acted upon by 4 forces, as shown in the figure. What is the acceleration of the box? So here I will draw the forces acting on the box, which is called the free body diagram. I have 10 Newton to the right, 10 Newton to the left, 50 Newton upward, and 20 Newton downward. So here we have the forces in horizontal and vertical directions. I will draw the x-axis and the y-axis. Then I need to get the net force in the x direction and the net force in the y direction. In the x direction, I have two forces, 10 Newton and 10 Newton. So 10 minus 10 is 0. So there is 0 Newton in the horizontal direction. In the y direction, I have 50 upward and 20 downward. 50 minus 20 gives 30 Newton upward. So the resultant here, or the net force, is 30 Newton upward. And we said last time the acceleration follows the direction of force, or the direction of the net force. So that means the acceleration is also upward. Okay. So the net force here, I have no net force in the x direction. So I have net force in the y direction. So this is the mass times acceleration. The mass is 5 kilogram. So the acceleration is 30 divided by 5, 6 meter per second square. And as we said, the direction is upward. Okay. So what happened if the horizontal forces also exist? Like if the net force is not 0. Yes, Muhammad?
Mr. Awashi, Assalamu alaikum. And I want to ask you, when we use it 6 meter per second square downward, when?
If the net force is downward, like look at the net force in the y direction. We have 50 Newton upward, that's a positive 1, and 20 Newton downward, that's negative 1. So we said 50 minus 20 is 30. So 30 here is upward. So the acceleration also is upward. Okay. So let's look to the other case. What if the net force in the x direction is not 0? Like let's cancel this 10 Newton here and consider only one of them. Okay. What will happen? So in this case, I will cancel this 10 Newton. So we still have 10 Newton to the right. So the F net in the x direction is 10 Newton. And the F net in y direction is 30. So here you have to do what, as you say here, Pythagoras rule. So we need to draw a triangle with a horizontal side 10 Newton and vertical side 30 Newton, and the net force will be the hypotenuse of this triangle. So this is the net force equals what? The root of 10 square plus 30 square, which is almost 31.6 Newton. So this is the net force. So the acceleration also follows this direction. So acceleration must be in this direction. We cannot say it's positive or negative. There is no meaning here to say the acceleration is positive or negative, but we will define the direction of acceleration by, let's say, an angle theta. Okay, but I will not say positive or negative, because positive or negative only regarding the x or y direction. But if it has an angle, you need to get the angle. But I'm not going to say positive or negative. It has no meaning. So in this case, the net force equals mass times acceleration. The net force is 31.6, The mass is 5. So the acceleration is 31.6 divided by 5, and you will get it. So the direction here is angle theta. So the angle theta, I can get it from tan theta. Tan theta equals the what? The y force divided by the x force. The 30 divided by the 10. So that's 3. Shift 10, you get theta around 71 point something, 0.2 or 0.3 degrees. Okay? That's if we have x and y direction for the forces. Yes, Turkey?
معلش بس الصوت بعض الأحيان يرتفع بعض الأحيان ينزل يكون مو بواضح.
Is it for everybody?
صحيح يا دكتور.
Yeah.
Now, is it working better or still low?
Now it's good.
Okay. If there is any problem, you can tell me in the chat. So let's move to the next one. An elevator whose total mass is 600 kilogram is suspended by a cable. معلق بواسطة كابل. Elevator means مصعد. So here we have an elevator. This elevator is suspended by a cable. Of course, this cable has a force. Okay, and the force in the cable, we usually call it tension force. Tension, it's like pull force. Okay, شد أو سحب. Okay, but in engineering we call it the tension force. قوة الشد. So here the elevator is 600 kilogram, and it's suspended by the cable that can exert a maximum upward force 15,000 Newton. So this cable is able to hold maximum force 15,000 Newton upward. And upward because it's pull or because it's tension. Okay, upward. What is the greatest upward acceleration of the elevator? How to calculate the acceleration of elevator here? Maybe you will say the force equals mass times acceleration. The force is 15,000 equals mass, which is 600 kilogram times acceleration. Then you will get the acceleration, whatever. Okay? But if you do that, then you forget something. What did you forget? You forget what? Can you answer?
W.
Forget what? The value of what?
الوايت.
The weight, right? So you forget the weight because if you draw forces acting on the object, there is the force of the tension, which is the 15,000 Newton, but there is also a downward force, which is the weight of the elevator, the mass times gravity. So do not forget it. So here I cannot say this one, but it should be the net force. The net force. So the net force here is what? The 15,000 minus the W. Why the 15,000 minus W? Because here he says the upward acceleration. Upward acceleration. And take care because we have two cases here. We have two cases. Upward acceleration means the acceleration is upward, so I will take the positive direction of my equation to be upward. Okay, So let's make it 15,000 Newton minus mg, which is mass times gravity, equals mass times acceleration, which is the mass is 600 times the acceleration a. So I can find the acceleration equals 15,000 minus 600 times 9.8 divided by 600. That will give you around 15.2 meter per second square. This is the acceleration. This is the maximum upward acceleration. What if he tell me that this is downward acceleration? Downward acceleration means the acceleration is downward. So the positive direction of your equation will be the downward. So you will make another equation or another problem. Force equals mass times acceleration. Now the weight is the positive. So weight minus force equals mass times acceleration. Weight minus force equals mass times acceleration. Okay, so we reversed the weight and the force sign, and then you continue according to the given in the problem. But I need you to take care of the sign. If I tell you, if he told you that the acceleration is upward, so take the upward to be your positive. If downward, take the downward to be your positive and continue your problem. Okay. If you press a book flat against the ceiling with your hand, in what direction is the friction force? Here we need to draw all the forces acting on the object. This is the book. Ceiling means ceiling, سقف. Okay, wall, حائط. So here you press with an external force F. What are the other forces? I have the weight of the object, mass times gravity. What else? What else? I have a normal force or normal reaction perpendicular to the ceiling. Perpendicular to the ceiling. I will call it N. What else? I have friction. This friction between the two surfaces. So it might be to the positive, a force, force to the right or a force to the left. So the friction force might be a force to the right or a force to the left. I don't know. So I will assume, أفترض, that it's a force to the right, for example. So this is the direction of friction force. So now I draw all the forces acting on the object. Then let's say this is X direction and this is Y direction. Do we have motion here? No, we have no motion. So no motion means zero acceleration. As we mentioned last time, if there is no motion, that means zero acceleration, and that means the forces are balanced. Balanced forces. What the meaning of balanced forces? The net force is zero. Net force is zero. So in the X direction, or let's start with Y direction. In the Y direction, forces are balanced. I have three forces. One of them is upward, the other two are downward. So they balance each other. So the upward force, which is external, which is the external force, this is the upward force, equals the two downward forces, the N plus W. Okay, so the external force, the force that you press on the book with, equals the weight plus the normal force of the ceiling. Okay, in the X direction, the net force also is zero. So I have friction force, I assumed it to the right. Do we have anything to the left? No, we don't have. We have nothing else. So there is nothing to balance the friction force. So that means the friction force actually is zero, because we said the net force in the X direction is zero. and we only have friction. So there is nothing to balance this friction. That means the friction itself is 0. The friction itself is 0. Okay? So the friction is 0. What if I get, let's say, there is a force in this direction, like there is a force 5 Newton to the left. In this case, the 5 Newton will balance the friction force, and you can say the friction equals 5 Newton. Okay, but as long as there is no forces in the horizontal direction, the friction stays 0. Somebody asked about what if the book is on the ground or on a table like this, and you press on the book by a force F. Let's draw the forces. I have the weight of the object downward. I have a normal force perpendicular to the table. Perpendicular to the table. Okay. I have friction. I don't know to the right or it will be similar to the previous case. I will assume it to the right. Assume this is your X and this is your Y. In the Y direction, I have a force downward, which is F. I have W downward, and I have the normal force upward. So the downward forces balance the upward force. So the force F plus the W, these are the downward forces, equals the normal force N. This is the upward force. See, there is a difference between this one and this one. So you need to draw the free body diagram. Okay, then you write down your equation. Okay. In the X direction, friction force equals what? There is nothing on the other side. There is nothing. So it's 0. 0 force. So also the friction is 0. But if there is, let's say, 2 Newton to the left, in this case, you will say the friction equals 2 Newton. But as long as there is no force, so the friction stays 0. There is a third case. Third case. What is it? If you push the book against the wall, like if there is a wall and you push the box by a force F against the wall. Let's draw the forces acting on the book or on the block. I have the weight downward equals mass times gravity. What else do we have? What else? We have the normal reaction or the normal force perpendicular to the wall, perpendicular to the wall, perpendicular, 90 degrees. I will call it N. I have also friction force. In which direction? We expect the motion of this block to be downward. We expect if this object slides, it will slide downward. So the friction will be upward against the motion or against the expected motion. So this is friction. Okay? Take this one is X, take the vertical one to be Y. Let's apply the net force is 0 or the balancing of forces. In the X direction, I have two forces. They are balanced. So the force F equals N. This one equals this one. Okay? And in the Y direction, I have weight downward and I have friction upward. So the weight equals the friction force. So this is the second equation. Like for example, in this case, I ask you, let's say, if the mass of the object equals 10 kilogram, if the mass equals 10 kilogram, find the friction force. Find the friction force. How to find the friction force? Here the friction equals to the weight. I have the mass 10 kilograms, so it's 10 times G. mg gives you 98 Newton. So this is a friction force. Good. I might ask you, if the external force equals 30 Newton, find the normal reaction or find the normal force. I know the normal force in this case equals what? Equals the external force. So it's 30 Newton. Okay, and so on. Okay, guys? So these are the three cases. A car with a mass 1600 kilogram. A car that has a mass 1600 kilogram, including the driver. So if you have, let's say, including the driver, its mass is 1600 kilogram. And it has a maximum acceleration 1.2 meter per second square. Okay, so this is the case. So what will happen when a certain passenger is also in the car? So if there is a passenger in this taxi or in this car, like another passenger here, we will add him to the car. He will ride in this car. What will happen to the acceleration? Now you increase the mass because you add another mass. Like let's say the mass of this passenger is mp. The mass of the new passenger is mp. So you increase the mass of the car. What will happen to the acceleration? The acceleration will decrease because the engine of the car produces a certain torque. Torque means azm. It produces a certain torque. Okay. If the car is empty, this torque can give maximum acceleration to the car. But if the car is full of people and luggage and this stuff, so you increase the mass of the object. And we knew from last time, if you increase the mass, okay, and the force is constant, that means the acceleration will decrease. So here, the engine does not change. It's the same engine of the car. But you increase the mass of the car because you add a lot of passengers or a lot of luggage or a lot of boxes inside the car. So the acceleration will decrease. So when you add this passenger, its maximum acceleration becomes 1.13. The acceleration in the second case becomes 1.13. What's the mass of this passenger? We need to find the mass of the passenger. So the point here is what? The force at the beginning equals the force at the end. Because it's the same car, the same engine. So the engine produces a certain torque, which we can convert it into a force. Okay, so the force here is constant, and I know that the force equals mass times acceleration. So in the first case, it's mass times acceleration. Let me call it m1 and a1. And in the second case, m2 times a2. So the first mass is 1600 times the first acceleration is 1.2. The second mass, we will see what is it, times the acceleration in the second case is 1.13. What is the second mass of the car? What is the mass of the car in the second case? It's the original mass plus the mass of the passenger. So it's the 1600 plus the mass of the new passenger. Okay? We can solve this problem. I can say 1600 plus the mass of the passenger equals 1600 times 1.2 divided by 1.30. I'll take the 1.13 to the denominator on the other side. Then you can take the 1600 to the other. It will be negative or minus here, minus 1600. So that will give you the mass MP. If you calculate this one, that's 1699 minus 1600. the result will be 99 kilogram. So this is the result of this problem. The mass of the passenger here is 99 kilogram. You have questions, guys? Questions? Yes, Muhammad?
This one question in the old exam, or where is the question?
Yes, it is.
In the old exams?
Yes. Any other question? You understand it, guys? Is it clear? Yes, Al-Muthanna? Go ahead.
I have a question about the homework, not.
No, please, like if you want to ask now, ask in the problem. If you have another question or something outside of the lecture, we can discuss it after the lecture. Okay? So a person is pushing horizontally on a box. So there is a box here on the ground, and someone is trying to push. Okay, someone is pushing the box with a force F. So he applies constant force, causing the box to slide across a rough means there is friction, a rough floor with a constant velocity. So this box moves with a constant velocity, whatever the velocity is, 2 meters, 3 meters per second, whatever. Then he says what? If the person suddenly stops pushing, like if you suddenly remove your force, you will remove your force. Okay? So you stop pushing the box. What will happen to the box? What will happen to the box? Immediately comes to a stop, or continue moving at a constant velocity for a while, then gradually slows down, or immediately change to a slower but constant velocity, or immediately slowing down and eventually stop, or continue moving at constant velocity. What do you think? What do you think? Which answer? You can write it in the chat here, please. You can add your answer in the chat. So most of the answers are between A and D. A and D. A here says immediately come to a stop. Immediately come to a stop. I'll ask you to do a very simple experiment. I think you might have a pencil or a pen in front of you. Just push it on the table or on the desk, okay? Then leave it. Then look what will happen, okay? So you will push it on the desk in front of you for like 1 second or 2 seconds, and then leave it. What will happen? It will slide for some time and slows down and then stops at the end. Okay, of course this will take like 1 second or so, but it will slide for maybe a few centimeters. Then while it's sliding, it slows down or it's slowing down until it stops at the end. So when you have an object that is moving and then you leave it, this object slows down, and eventually at the end it stops. So this is the right answer. But you cannot stop it immediately. You cannot do that. Okay? So even in the collision, التصادم, the object takes some time to stop, even if this time is in microseconds, or in some cases in nanoseconds, or maybe less, if you are talking about very, very small particles. But also there is a time needed for any object to stop. We cannot bring any object immediately to a stop. We cannot do that. Okay, there must be some time. In some cases, the time may be a few seconds, and sometimes it's less than a second. Okay, so number D is the right answer. Of course, number D. So number B says what? Continue moving at constant velocity for a while. It will move at constant velocity for some time. Why? Here you have a rough floor. Rough floor means it cannot move with constant velocity. You remove your force. So the only force now is friction. And the friction causes slowing down because the friction produces deceleration. The friction produces deceleration. Okay, so it immediately it slows down. Immediately slows down because of the friction. Number C, immediately change to a slower but constant velocity. Of course not. It will not move also with constant velocity. The last one says what? Continue moving at constant velocity. Also, it cannot move with constant velocity because of the friction. Do you know if you remove this, if you remove rough floor and make it smooth floor, what will happen? In this case, there will be no friction. There will be no friction. And this is not a real case, by the way. This is not a real case. But let's assume you are on a smooth surface. Once you leave it, the object continues to move in a straight line with constant velocity forever. That's Newton's first law. Okay, so it will continue moving at constant velocity in case of a smooth surface or a smooth floor. Okay, which is not a real case. Which is not a real case. Yes, Abdul Muhsin, what's your question?
You spoke about friction, doctor, but you forgot about air resistance. If there's air resistance, it will also slow down.
Actually, the air resistance, yeah, you are right. But the air resistance, actually, it's proportional to the speed. And here, in this case, we are talking about like very low speed, like 1 meter per second, half meter per second. So the air resistance here is negligible. Air resistance is considered in high speeds because it's proportional to the square of the speed. The air resistance, it's proportional to the speed square. So if you are talking about an object that's moving at 50 meter per second, 100 meter per second, 500 meter per second, so you are fine. You have to consider the air resistance. But when you talk about a box on the ground at 0.2 meter per second or 0.1 meter per second, so comparing to the friction, it's negligible. Okay, understand this point?
Okay, got it. Thank you.
Yes. A small car is pushing a larger truck that has a dead battery. The mass of the truck is greater than the mass of the car. So I have a car and the truck, and the car pushes the truck. So which statement is the right statement? About the force they act on each other. I think you solved this one in the homework, maybe. Which one do you think is the right one? According to Newton's third law, if all pushes the other with the force F, the other one will push it back with the same force. Okay, so the truck exerts the same amount of force. But why both objects move with an acceleration? I said last time, to get an acceleration, there must be an unbalanced force, or the net force has a value. And now you say, I have two forces against each other, this F and this F. So where is the force that causes acceleration? I will tell you, it's the external force comes from the tires, okay? The friction on the tires of the car. These are external force F, or let's call it P. So this force B is external force. it will push both of them, and it will accelerate both of them. Okay, so this is an external force, while the force F, okay, it's the action and reaction here, they cancel each other, or they are against each other and they are equal. Okay, three masses are located as shown in the diagram below. The distance between M1 and M2 is the distance x1, and the distance between the mass M2 and M3 is the distance x2. What is the net force on the mass M2? So here we are talking about gravitational force. Gravitational force. There is an attraction between M1 and M2, and there is an attraction between M2 and M3. So he's talking about M2. What's the net force? The net force on on M2, if I assume this is called Fr, and this is, let's say, Fl, the right force and the left force, equals the right force minus the left force. So how to calculate the right force and the left force? Gravitational force. The left force equals what? It's between M2 and M1. G times the mass M1, the mass M2, divided by the distance square. This is the equation of gravitational force. What about the left force? Fr equals G times the first mass M2, the second mass M3, divided by the distance square, so x2 square. Here he says what? M3 equals 4 times M1. He mentions that M3 equals 4 times M1. So I will remove M3 and write down 4 times M1. And also x2 equals 2 times x1. The distance x2 equals 2 times x1. So I will remove x2 and write down 2x1. But take care that it's squared. So if it is squared, I can write it again as 4 times x1 square. So I will remove it and write it 4 times x1 square. Okay? Then you can remove this 4 with this 4. So the leftover here is what? G times M1 times M2 divided by x1 square. So this is the right force. So the net force equals Fr minus Fl. Look at two of them, they are the same. So the result is 0 because they are the same. So the right force equals the left force, and the net force will be 0. Okay, guys? Let's move to something else. Some applications for Newton's laws. Some applications. These applications are car crash and its relation to Newton's first law, which we call it the inertia. القصور الذاتي, the inertia. So what's the relation between the car crash and the inertia, or Newton's first law? Then the effect of the air resistance. The effect of the air resistance and its relation to Newton's second law. Then the law of conservation of momentum. Momentum, as you know, زخم. Conservation means that you save the amount. Conservation, that you save the amount. You keep the amount unchanged. Okay? In Arabic, we can call it الحفاظ. الحفاظ على. So we conserve the momentum. Okay? Yes, Abdurrahman, the last problem, it was 0. Yes. So Newton's first law says what? An object at rest will remain at rest, and an object in motion continues its motion in what? In what? Straight line with constant speed, unless an unbalanced force acts on it. So this is Newton's first law. So let's see this video and look at a car while crashing. What happens to the occupant or the passengers inside? Okay. So this is the law of inertia, Newton's law. Okay. So usually we use seat belts. Without seat belt, what happens if there is a car crash? The occupant here, the passengers, because of his inertia, he moved forward. Okay, so he carried on until maybe he will hit the windshield. Okay, but if you have the seat belt, if there is a seat belt like this case, the seat belt might hold you in your place. Okay, so the seat belt has a function that it prevents your inertia, so you will not hit anything. Okay, also there is another part here that we can look at it. It's the upper part of the seat. It's not like to rest your neck. No, it's also for the accidents. This is also to save you from the accidents. Okay, so it's not for your comfort. Of course, be for your comfort, but it's also for safety. So here, if there is a car crash, the car stops momentarily or immediately in like 0.1 second. Of course, there is a time, but very, very small time. In 0.1 second or 0.2 seconds, okay, that means 100 milliseconds or 200 milliseconds, the car stops in the crashes. Okay, so because of the inertia, you might fly off, or you might continue your movement, and you might hit any part of the car, or sometimes you might fly off the car. Okay, so here we need the seat belt, because the seat belt will apply a force on your body. This seat belt will apply a force on your body, and we will keep you and the seat as one object. And of course, the seat is part of the car, so it will keep you and the car as one object. Okay, so it will prevent your inertia. Okay, so you will not hit any part of the car, and you will not fall out of the car. Okay, guys, so this is the function of the seat belt. During a car crash, if there is a car crash, the force needed, the force coming from the seat belt, حزام الأمان, the force needed to slow person's speed from 50 kilometers per hour into zero in a time 0.1 second, it's around 14 times the force of the gravity. See, it's very high force, around 15 times the force of the gravity. Let's try to calculate it using some numbers. In a head-on collision, a car stops in 0.1 second. So the time, this is the time, 0.1 second. The car stops, meaning its final speed is zero, from a speed 14 meters per second. So this was the initial speed of the car. So a car that had a speed 14 meters per second, it has an accident, so it stopped in a time 0.1 second. The driver has a mass 70 kilograms, so this is the mass of the driver, and he is tightly strapped into his seat, so he attached the seat belt very tightly. So if you attach it very tightly, okay, it will prevent your inertia. Okay, so you will not hit the steering wheel or the front shield, the windshield. What force is applied to the driver by the seat belt? We said there is a force applied by the seat belt. What is this force? I know force equals mass times acceleration. So you are the object. Your mass is 70 kilograms. And this seat belt applies a force on you. So the force will equals what? Equals mass times the acceleration. So your mass is 70 kilograms, and the acceleration is the deceleration of the car. Okay, the deceleration of the car, because it presses on you with this deceleration. Without this one, you will fly, you will continue your motion. But this force Okay, it presses your body not to fly off the car. So the acceleration here equals what? V final minus V initial over time. V final is 0. V initial is 14. Divided by the time, it's 0.1. So the total here is negative what? 14 over 0.1, that's 140. Of course, negative. And negative here means what? What's the meaning of negative here? What's the meaning of negative acceleration here? This is because the direction is, again, the direction of acceleration, or the direction is of force, is opposite to the motion. The motion is forward, while the force is backward. So the force will be negative. Okay, again, is the motion, or in our drawing, it's to the left. But we should say it's opposite to the motion. So it's negative 70 times 140. That's total 0.089 Newton. So the value of force is 9,800 Newton. 9,800 Newton. See, it's a very huge amount of force. Very huge amount of force. This acts on your body, on your chest or body. Okay, but lucky you are, it affects you only for 0.1 second. Only for 100 millisecond. Not more than that. Okay. If we try to find the equivalent mass of this force, what is the equivalent mass of this force, guys? The equivalent mass. Do you know? Divide it over the gravity. So the equivalent mass of the force of the seat belt is around what? 1,000 kilogram. 1,000 kilogram. This is the equivalent mass of the force of the seat belt. It's like you are carrying 1 ton of material on your chest during the accident. Okay, 1 ton. 1 ton, it's on your chest during the accident. Of course, it's very small time. That's why it's not affecting you or it might not break your bones. But of course, after these accidents, people, they feel pain in their body for several days. Or maybe it might break something in their head, or sorry, in their chest or something. Okay? Okay, so thank you so much. That's the end of this lecture. Please, if you have a question, you might ask.